All right, hello there. This is Garrett, the artist, and we are going to be telling you today how to record data on the CL1 platform. So, as we could see here, if we look, we see the CL1 dashboard, and we also see here the recording, the recording for live data into HDF5 files. So we're not working with JSON, we're not working with CSV, we're working with HDF5, which is the data format. To give you some context, this data format is often used in financial settings, medical settings, and sometimes I'm trying to think of any others that might be pertinent, but for probably some forms of hardware engineering where you need very, very granular data that can be reformatted to suit the needs of the project. And in this case, we're dealing with biological data. So let's jump right in. I'm just going to go ahead to this first cell in the Jupyter notebook, and I'm going to go ahead and click Run. We are going to go over in a moment what exactly this code is doing, but it's important to start in the simple case here, which is we're starting with an open-ended recording. We open a connection to the neurons, as you can see right here. So CL.open as neurons, as we've done before. Recording equals neurons.record time.sleep 3. Okay, so, and then we stop the recording down here, and we could see that there was a 3-second recording, as you can see right there, 3 seconds. And, it stopped that recording and printed out how many frames were captured when the file was saved, and we could see that right here. Um, so this is probably one of the more useful things, the most useful things when you are coming in and working with this platform because, you know, I just got done on this exact machine that you see here, going in and on a 10-hour run, doing some stimulations and having to essentially ensure that, hey, like I know how I'm going to improve my code after the fact. And you'll see H.H5 here as well. So the format is H5. You can convert that to being something else later on if you need it, and we might go over that in another video, but I highly, highly recommend you work in the HDF5 format. So in the second cell right here, we're going to run. And this is basically, but what if you're recording something of an exact length? Instead of manually stopping, you're able to tell the system to just stop itself. So that's what this cell is doing right here. And we could see another one, basically 3 seconds flat, stop after seconds. And, this ends up, you'll see there's a little discrepancy because, you know, that first one ended up running a little bit beyond 3 seconds due to, this is a sleep, just telling it to sleep. But this is chopping it right at 3 seconds. So stop after seconds 3, right there. Very, very similar, but we're using recording.wait until stops here, and that basically allows us to have, um, precisely 3 seconds, and we're noticing that we have exactly 7,500 frames. So, it just being, when you're trying to be very scientific with your data and you're trying to get things so it is exactly what you need, when you're going back to look over things, it's not a big mess. It's very important to, be kind of using this as you know, um, thinking ahead of time, in terms of data sanitation. So we're going to run now based on the corresponding number of frames. So going off of the frames instead of the time. And I'm just going to hit right here and we're going to wait for this to run through. And this is basically, we still see 7,500 frames, 3 seconds, but you could think in frames rather than seconds. So by passing stop after frames, so if we pass stop after frames right here, and then, get the frames per second for 3 seconds, which we already know is 7,500, we're able to, do a similar type of thing here, but based on the frames. So these are two different ways of getting a clean 3-second recording, But it's like you can either go by the frames or you can go by the second, and there could be different scenarios where you'd want to use frames over seconds, and we'll go into that again in a future video. But opening a recording file, here we go. We can look back at our recordings, and you could see some matplotlib coming in here as PLT. We're gonna just wait for this to bounce back, and it's a very interesting piece of code because you're going to be doing a lot of this, just wanting to output your data in a visible format. And again, here we're looking at channel 2. Channel 2 is right here. There's not a lot going on channel 2 right now. So we can even go in here and change it to one, let's say channel 51. And, you'll see a stark difference. We're going to just run the code, run in blocks of code here. Let's see, channel 51, and we'll just run it one more time because I'm trying to get some more visibility on here. But yeah, you could see you know the I think we're doing, yeah, it might be a good one on the next one to do. So we'll come down here on this next one even. It will just run these two because I just want to kind of explore it. Okay, yeah, channel 51. So this here, we're on a kind of heavily spiking channel. You're able to actually see something going on. Okay, so there's a good amount of spike activity, but what's happening here? So how can we explain this better? Well, let's just jump back into this first piece of code. Um, when you're looking, basically, when you're looking at the plotting spikes with plot spike, and I think, let me see, plot spike, I believe is down here. But if we're looking at, having a recording and, reading it back, this is, it's very important. And beyond raw samples, creating, recordings can actually capture these detected spikes. And, here we sort the spikes by amplitude and grab the 5 largest. And I think, let me see right here because I'm trying to explain this the best. Right here, so we're grabbing the 5 largest right here, the 5 largest spikes, and plotting them, using matplotlib, using tables. And then up here, we're plotting them based off of time, so this is, purely time-based, plot frames, channel, and, we're working with it on a time basis right here. So, these raw samples can be easily retrieved from a recording. And, that's one of the advantages of working with HF, HFPY and HDF5 library, so it's, helpful because we're working with very granular data that we can trust, that it's in a reliable format. And, it just makes our lives easier. And, it's, important to be able to look, also into each timestamp. We're able to look at, the spikes, which you can see happening right here, that are happening at different timestamps. So sorting them per the specific timestamp, being able to look at the scenario that surrounds that spike, and hey, like return to baseline is a very important piece of research. And here is the last one, and we're just gonna just run that real quick. But the very last one is a highly configurable, calling help on it reveals all the options that you can set, custom file names, locations, start recording from the moments in the past, control exactly what gets included, spikes, stimulations, raw samples, data streams, and more. And, I highly recommend looking very deeply into this. And again, this is another kind of more exploratory video where I want to spend some more time digging into, hey, we have this import CL package here. It's essentially like, hey, you've got a bunch of different Legos, and when you run the help method on neurons record right here, you get all those, right here, and you can find them in the documentation on GitHub. But it's very important to start thinking creatively, before you just jump in with an agent, but think creatively about how you can use these different recording methods to bolster and strengthen your research approach. And what does that mean? It means taking the best approach for what you are trying to accomplish. If you're trying to, for example, train the neurons to do something, that is one approach. If you're trying to potentially be more on the side of recording what they're doing, I know that these devices are used in a lot of neurotoxicity studies for drugs, for testing drugs. Um, but it's very important to just kind of be able to fit the code to what you need to do and what you want to accomplish. So on this, you know, I think we'll close it out here, but I do intend to get a little bit more technical, especially in these two areas in future videos, because, I think we got a very good understanding of it in this video, but as you could see down here, all the different recording options that you have, there's so much that you can do, so much that you can accomplish. So we'll just be done right here on this part of the video, but I do want to encourage you. My email is going to be in the description of this video, and I'm also always available to help anybody that is trying to get started on this platform. And my personal goal is to use data to bring 1 million developers into the world of biological intelligence, by making, these types of systems more accessible to the general public and more accessible to, humanity as a whole. So I really want to thank you for watching through this video. If you watched through the whole thing, congratulations. And, I really, really wish you the best on accomplishing whatever you want to build with neurons on a chip. So thank you very, very much and have a wonderful rest of your morning, evening, or afternoon.